Now, our main concern about resistance in a circuit is this concept of total resistance of a circuit. It will become apparent why this is important when you cover Ohm's law under this chapter. Alright, so when we compare the total resistance of a series circuit with that of a parallel connection, the method is different. Okay, so imagine a circuit where you have R1, R2, R3 arranged in a series circuit. The idea behind this total resistance is how much resistance in total does a charge have to overcome when it comes off of the battery and by the time it goes back to the battery for more. Alright, so what the charge encounters is first R1, then R2, then lastly R3. So the total resistance of a charge going through a series circuit is very direct. It's R1 plus R2 plus R3. It's very natural and all of us will understand that. Now, what about a parallel circuit where you have, let's say, 3 branches and first branch has R1, second branch has R2, and third branch has R3? What kind of total resistance does a parallel connection like this actually have? Well, then in this case, I will strongly recommend that you just memorize the formula that allows you to calculate this, because it is a little bit complicated to explain why it should be so. So what is the formula? 1 over total resistance of a parallel circuit equals to 1 over R1 plus 1 over R2 plus 1 over R3. 3 fractions added together. Remember to calculate for common denominator, adjust the numerators and add them all up, but all the time keeping them in fraction form. Then the final added up fraction, that will only be 1 over RT. Okay, 1 over total resistance, that's not the answer yet. So what do you do with that fraction? You flip it. Okay, you flip it. Therefore, then total resistance will be that final fraction flipped around, and therefore you can now put an ohm to it and then say that that is the calculated total resistance of the parallel arrangement.
Stay tuned for more contents. Click the plus for more info.